I'm going to give a little demonstration here on how to make martensite and also show you some other heat treatments we can do with steel. To do this demonstration, I'm using little bobby pins. Bobby pins are good for this example because they have a decent amount of carbon in them, which is a key ingredient to have in order to be able to make martensite. Because if you have a very low carbon steel, you're not going to be able to make martensite. But there's enough carbon in the steel in a bobby pin that you can do it. So what I'll do is I'll just straighten this out. First of all, just take a look at a regular bobby pin. It's pretty stiff. It's not, I mean, it's easy enough to bend around, but you can tell it's a little, there's a good amount of strength to it. What I'm going to do then is I'm going to heat it up on the stove and put it right here in the flame. It'll burn off the little coating on the outside, and then after a while you'll see the steel become red hot. And that's a good sign that you're actually turning it into austenite. So we're going higher on the phase diagram to get completely austenite. Think of a face-centered cubic crystal structure instead of the body-centered cubic crystal structure it is at room temperature. So make sure it's fully austenite, and then what I'm going to want to do is cool this very fast. So I'm going to try to get this over to the ice water bath as quickly as possible. Here it goes. So that I can quench it. So quenching it from austenite down to room temperature forms martensite. And if you look at it, you can't tell a whole lot. It's a little dingy on the outside, but what we can really tell is when we try to bend this. If I try bending this now, remember, martensite, very strong, but also very brittle. Look at that. Very brittle. We formed it into martensite. Good amount of strength to it. It's because it's pretty stiff, pretty strong, but as soon as I give it enough strength, it just snaps in two. So you've lost all the ductility into it. Let's try the same thing now. So let me form martensite, and then let's try tempering it. Remember, once you form martensite, you can create tempered martensite, which is actually a more desirable product, because basically what you're doing is when you form martensite, it creates that metastable phase, and that metastable phase doesn't really want to be there. It's kind of locked into that phase, and by tempering it, you're going to allow it to form ferrite and cementite, but it'll be on a very fine scale, so it will be still very strong. So here it is. I've got it into austenite. Quench it. So now I've got martensite. And now to temper it, I don't want to austenitize it again, but I just want to kind of heat it up a little bit. So it's kind of tricky. You want tricky when you're doing it on a stovetop because you don't have all that much control. But basically I want to heat it up enough that I'm allowing the ferrite and cementite to separate. I think that's it. I don't want to quench it this time. I suppose it wouldn't really matter to be quenching because it's not austenite. Hopefully it's not austenite. Just cool it off enough that I can touch it. And let's try this. Hopefully I still have a good amount of strength for the tempered martensite, but it's not as brittle anymore. And that is what I'm saying. You can see the ductility's back. I can actually bend it. And it's a pretty stiff material here. So I believe I've been successful in creating tempered martensite, where it's pretty hard, but it's still ductile. At the other extreme, we could make a very soft metal. And to do that, we want to do just the opposite. After forming austenite, instead of quickly quenching it and forming martensite, we want to cool it down as slowly as possible. So let's try this one out. So I'm going to create austenite. So I want to get it all nice and red hot. And then I want to try cooling it down as slowly as possible. I could just take it out and air cool it, but I can actually go slower than that if I just slowly draw it away from this flame. So Once I'm sure that I got it all in austenite, what I could do is let's try this. I'll just turn down the flame slowly to try to slowly cool it down and try to draw it away from the flame. You'll see that the redness is starting to cool off. So we want it to cool down slowly. We're giving it plenty of time to form into ferrite and into pearlite on a very coarse structure, because the slower you cool it, the coarser the structure is going to be. So the slower I can go here, the more soft and ductile the iron's going to be in the end. So I have to be patient. And you have to be patient too. I'm just going to lift it up higher. It's probably pretty close now. Slowly draw it away from the flame and let it cool. Turn that off. And hopefully cool enough that I can touch it. The slowest cool they would do industrially is they would put it in a furnace, heat up the furnace, and then just turn off the furnace so the whole furnace slowly cools down. And that's a very extremely slow cooling process. Slow enough you could probably form something like spherodite. Okay, now it's cool enough to touch. And let's see how soft I made this. It's hard for you to see. You can see that it's very ductile because I'm just bending it back and forth. When I'm doing it, I can tell that it takes a lot less stress, a lot less pushing to bend this around. It's a lot softer than that original bobby pin was. The original bobby pin, to bend that around, gives you a lot of resistance. You got to really kind of force it to bend. It's a good amount of strength to it. But this slowly cooled steel is much softer. You can feel that as you bend it around. So you can see the importance of heat treatment. From one end, a fast quench that created martensite. Very strong, but very brittle. The other extreme, heat treating and then a slow cool to create a very coarse or large scale structure of ferrite and pearlite. And you end up with a much softer steel. And these are the kind of processes that metallurgists, materials engineers would use to create a steel that's just the right properties for what you want.